All right, so welcome back. This is an ALEKS topic that's called Identifying Hydrogen Bonding Interactions Between Molecules. This is another requested video, so again, thank you for the request. And this is a great topic. I really like this topic. It seems like it could be very simple because we just have to answer yes or no, but there's actually a lot that goes into this topic that we really need to understand before we can actually do the topic. So we're gonna go ahead and get into that. In this video, I'm going to go through 3 different versions of this problem. So we're not just going to do these examples here. We're going to take our knowledge that we gained in the first part of the video to apply it to a bunch of different situations. So let's go ahead and get started. The first thing that we really need to talk about is what a hydrogen bonding interaction or hydrogen bonding force is. And the way that I like to depict a hydrogen bonding interaction is like this, where X equals O, N, or F. So this dashed line here, that's really what we're talking about when we say hydrogen bonding force. And really what a hydrogen bonding force is a really strong dipole-dipole interaction. So those of you who are taking chemistry right now, you might be talking about intermolecular forces and dipole-dipole interactions. And a hydrogen bond is really just a really strong special case scenario hydrogen dipole-dipole interaction. So dipole-dipole, if you remember or if you know, is when we have a partial positive that's attracted to a partial negative. And if I have this situation here where I've got X bonded to hydrogen and then another X atom over here, well, I'm going to have that really strong dipole-dipole interaction such that we're going to give it a special name. We're going to call it a hydrogen bonding force or hydrogen bonding interaction. So if we think about what's going on here, I've got O, N, or F, and you'll notice that all of these are small, highly electronegative atoms or elements, and I've got X bonded to a hydrogen here. So this is a covalent bond. So these, electrons here, they're being shared between this X and this H, and they're going to be shared unequally, right? If O, N, or F, highly electronegative, is bonded to hydrogen, we're going to be pulling electron density away. So this X over here would have a partial negative charge. This hydrogen will have a partial positive charge. And over here, I've got another O, N, or F with a lone pair of electrons. So these 2 dots here, those represent a lone pair of electrons. That's very important. Maybe we'll even label that. Lone pair electrons. And there's going to be an attraction, a dipole-dipole attraction between the partial negative of this highly electronegative element and this partial positive on this hydrogen. So a great example of this is a water molecule. So the reason why this question is asking about water molecules is because water is sort of the most common thing that we're going to run into that has this hydrogen bonding interaction. So we'll start with this water molecule here. Oxygen to hydrogens, very common. And we should know that this oxygen is going to have a partial negative charge. It's a polar molecule, partial negative charge, and these hydrogens are going to have partial positive charges. Now, this hydrogen here, it can have an interaction with another water molecule. So on this oxygen here, I would have a lone pair of electrons, right? Lone pairs of electrons. That's what gives this its bent shape. And the interaction here between the hydrogen and the oxygen, that's going to be what we call a hydrogen bond. It's confusing that we call it a hydrogen bond because when we think about bonds, covalent bonds, ionic bonds, we're thinking about these sharing of electrons here, right? This sharing of electrons, a covalent chemical bond. And a hydrogen bond is really just an intermolecular force. It's from this partial positive charge to this partial negative charge on this oxygen. There's going to be an attraction here. And that hydrogen bonding attraction, that's what we're talking about in this problem. Okay, so let's go ahead and get into some examples now that we know what a hydrogen bond is, and we can hopefully identify it. So the first thing here, we've got hypochlorous acid, and I really don't like that they gave you this one first because it's sort of confusing. The thing that we need to sort of keep in mind is what the actual Lewis dot structure for this species looks like. So here I've gone and drawn the Lewis dot structure for this hypochlorous acid. And so from this is what we're going to then base our answer to the questions off of. And I can see if this is hypochlorous acid, then I could actually draw another one of these such that I have this hydrogen bonding interaction. So if I draw another, let's just draw it like this, HOCl, some lone pairs of electrons here. From this hydrogen to this oxygen, that would be a hydrogen bond attraction, hydrogen bond interaction or attraction or force. You'll hear it sort of in all these different ways. And this fits our sort of criteria for a hydrogen bond. I've got hydrogen bonded to X, O, N, or F. That hydrogen is then interacting with a lone pair of electrons on another O, N, or F atom or element. So this right here, that attraction, that can be set up and we can have that hydrogen bond. Furthermore, if I've got a water molecule, again, that water molecule could do the same sort of interaction. I'm not going to draw that. Maybe we'll just use this model here. So from this hydrogen here to this oxygen, that would be another hydrogen bonding attraction or force. So for this one, I'm going to say yes for both. Now, if you don't have the proper Lewis dot structure, you're screwed, right? There's no way you can do this. So for hypochlorous acid, if you're not sure or you're sort of struggling with this, I would say go ahead and just Google hypochlorous acid, look up what the Lewis dot structure looks like, and then base your answer off of that, right? So for this next one, methylamine, I'm looking for nitrogen with a lone pair hydrogen. That would fit here. So if I've got nitrogen to hydrogen, that fits this part of our criteria. And then another, between molecules of the same compound, another methylamine molecule could then form a hydrogen bond with this lone pair of electrons here. So this lone pair of electrons on nitrogen, that would fit over here. So I could have sort of an interaction between those. If I wanted to sort of draw it, maybe I would try to squeeze everything in here. So this would be this part and then CH3. Got a lone pair of electrons there. So between this lone pair of electrons of nitrogen and this hydrogen, and also from this nitrogen here to this hydrogen, we could draw in that hydrogen bonding interaction. So again, yes, and if it can do it with itself, then it can obviously do it with water, so that would be yes as well. Hydrogen bromide, it's not going to fit. Bromine is not O, N, or F, so it is no for between molecules of the compound. And it's also going to be no between molecules of the compound and of water. So if I have HBr, so let's go ahead and just draw this one out, and I try to form a hydrogen bonding interaction with water, there's no way that I can sort of line these up that fit this criteria. The closest I think that we can come is if I think about this interaction here. I've got oxygen with a lone pair of electrons, that would be this part of the criteria, but this hydrogen is bonded to a bromine. So that bromine is not going to sort of fit this criteria. Furthermore, if I think about, well, I've got lone pairs on this bromine, can I form a hydrogen bonding reaction this way? Well, again, no, you can't, because this bromine is not O, N, or F. So this bromine will not fit this criteria. So that's going to be no and no. All right, let's keep going through a few more examples. So here we've got just some new examples. Difluoro Methane. And again, I would encourage you to draw out the Lewis dot structure. So I'm not going to show some stereochemistry, but that's the Lewis dot structure for this CH2F2. We'll put in our lone pairs of electrons here. So again, for between molecules of the compound, no. And the reason is because neither of these hydrogens are bonded to O, N, or F. So again, remember we've got X. This is what we're looking for. So I might encourage you just to draw this and we'll sort of see, can we fit into that criteria. X bonded to H, that does not exist in this molecule, so that should definitely be no. Now, for between molecules of the compound and molecules of water, this is going to be a yes. And the reason is because this fluorine can fulfill this part of the criteria. We've got X with a lone pair of electrons, so I could have an interaction that looks like this between this fluorine and the hydrogen of a water molecule. That is a hydrogen bond right here. Hydrogen bond. So that would be a yes for that one. Continuing on, we're going to have NH3. Again, there's a lone pair of electrons that they're not showing you on NH3. So NH3 is going to be a yes and a yes. We've got a lone pair of electrons on nitrogen, that would fulfill this part. And then nitrogen bonded hydrogen, that would fulfill this part. Ethane, we've got all CH bonds, that's going to be a no and a no. Again, we don't have this X bonded to H, and we've got no way to form a hydrogen bond with water. So no and no. All right, one more set here. So the last set, we've got CH2Br2. That's going to be no and no. That's similar to the CH2F2, but in this case we've got bromines, and bromines aren't going to fulfill our X requirement. Here we've got acetic acid. This is going to be a big yes and yes because of this OH here. We can form hydrogen bonds with itself. Anytime you see that OH or NH, pretty clearly that's a yes. And then methylamine, we already did this one, yes and yes. All right, so hopefully those examples answer all of your questions, and also our discussion of what goes into, an actual, let me get my page back here, what goes into an actual hydrogen bond. Hopefully that's clear. If not, definitely comment below. Let me know what you have questions about. Cheers.